If I may just go ahead and get started. Uh, my name is Imad Al-Qari. I'm a professor in the Civil and Environmental Engineering and directing the Illinois Center for Transportation. And I would like, on behalf of my colleagues in the transportation group, to welcome you all to our annual Distinguished Kent Lecture. Paul Kent was a 1920 alumnus of the Civil Engineering program who held the highest regard for the civil engineering education he received. He became a civic servant in Illinois and the surrounding states, and he also established his own contracting business. Mr. Kent was the founder and president of the University of Illinois Civil Engineering Alumni Association, which becomes the largest of its kind in the country. He was the recipient of the U of I Loyalty Award and the Civil Engineering Distinguished Alumnus Award. Today, we are celebrating Mr. Paul Kent by inviting a very distinguished and highly respected speaker, Professor Chris Hendrickson. Professor Hendrickson is the Hammerschlag University Professor of Engineering Emeritus and the Director of the Traffic 21 Institute at Allen University. He is a distinguished member of ASCE, a member of the Engineering, Chair of the Transportation Review Board's Division Committee, and Editor-in-Chief of the American Society of Civil Engineering's Journal of Transportation Engineering Part A, which is the systems. Chris' research interests include engineering, planning and management, transportation systems, design for the environment, system performance, construction project management, finance, and computer applications. Needless to say, in my opinion, he pioneered the work on life cycle assessment for transportation systems. He earned his doctorate from Massachusetts Institute of Technology, a master's and a bachelor from Stanford University. I have known Chris for so many years, and we work on many different committees, and I have very high respect for all his ethical work and pioneering work in the transportation system. Please turn your camera off during the talk, and you may turn it on after the talk. Please keep yourself muted all the time. You may ask questions through the question and answer, and I will read it, or raise your hand and you will be unmuted to ask the question. Now, please join me in welcoming Professor Hendrickson to talk about accelerating decarbonization in the US transportation system. Chris, welcome, and the floor is yours.
Okay, thank you for the introduction. I'll try and share my screen at this point. Let's try that again. That didn't work. Okay, that worked. Can you see my slides?
No, we see your web.
Let me try that again. I'm sorry.
That's okay.
Hit the wrong button. How's that?
That sounds great.
Okay. So this is an opportune time to talk about decarbonization of the U.S. transportation system. It's Earth Day, so happy Earth Day. And it's a day in which the Biden administration continues to try and push their policies with regard to climate change. And so some of the things that I'm talking about are of concern in the policy world in Washington, D.C. A motivation for why this topic is of interest, we're all experiencing climate change. Going along with climate change is sea level rise, particularly as the ice packs start to melt. Heat, we're setting records with regard to average temperatures on an annual basis now. Droughts, we have a pretty severe drought going on in the southwest of the United States. And then extreme weather events are on the uptick. That includes hurricanes and things like cold weather events that happened in Texas. There are conventional air emissions health effects. We're burning a lot of fossil fuels that results in conventional air emissions, and those have health effects. Things like small particles cause health problems. A third reason is that long-term sustainability is an issue here because fossil fuels are a finite resource. We're gonna burn them up at some point. Another reason is that ongoing technology development and alternatives to fossil fuels exist. We're all familiar with things like renewable wind power, but there's a lack of US manufacturing of some of the components there. And then finally, the political tides may be turning towards decarbonization. And by political tides, I include not only the folks in Washington, D.C., but a lot of state legislators, a lot of cities. And in addition to that, corporations are starting to advance decarbonization goals. And so you're starting to see some more action at a whole bunch of levels. This is a slide just to illustrate what I'm talking about. The vertical axis here is million metric tons of carbon dioxide equivalent being emitted in the United States. The horizontal axis goes from 1990 up to 2050. And the historical record is shown up until 2020, and then just a hypothetical trajectory towards deep decarbonization going forward from 2020 to 2050. The blue area in this graph are carbon dioxide emissions. The orangish graph area is non-carbon dioxide gases. You can see that even at 2050, when the black line, which is net greenhouse gas emissions, goes down to zero, we're still emitting some greenhouse gases to the environment, but we're assuming that those emissions are offset by land sinks. And kind of at the end of that period, 2045 to 2050, we may be able to introduce some negative emissions technologies, which actually pull carbon dioxide or other greenhouse gases out of the atmosphere and sequester them in some fashion. Now, if we don't do anything, the business as usual sort of trajectory is shown up the dotted line. If we start introducing some policies that lead to deep decarbonization, we might be able to go down a trajectory that gets down to net zero by 2050, and that's what basically I'm going to be talking about. Net zero pathways are going to have enormous implications for employment. What you hear in the popular press immediately is job losses in the petroleum and the coal industries, coal miners in West Virginia, for example. But at the same time, if we're on a net zero trajectory, we have the opportunity for lots in the renewable energy, putting in power transmission lines, carbon capture and storage, vehicle charging, building energy efficiency would be a big source of jobs, and research that's needed. So all of the students who are listening to this lecture, one of the messages, this idea of deep decarbonization could mean lots of new opportunities for not only in the United States, but also elsewhere. I have been working for a little over a year on a National Academies study. This is the National Academies of the Sciences, Engineering, and Medicine. Accelerating Decarbonization of the US Energy System is the report that we came out with in January. Our first meeting was back in March of 2020. And at that meeting, we said, gee, given the prospects of a Democratic administration, it would be good to get a report in the hands of the administration right around the time that the administration took over. And so we planned out doing this report, the Accelerating Decarbonization of the US Energy System, over a period of 11 months, which is moving pretty quickly for the National Academies, actually. We basically relied on the existing literature. We had access to a net zero study that was going on at Princeton, and we relied on the wisdom of the committee that's doing that. Now, rather than talking about the whole report, which would include manufacturing, building systems, power grid, and that sort of thing, Ahmad and I agreed that what this talk would do is focus on the transportation system. What you're going to get from the talk is basically the transportation system recommendations in the report, but also a little bit of an extension ideas about examples and kind of digging in a little bit deeper than appear in the report. The report itself is 200 very dense pages. It's available for download. I'll give you the download website at the end of this talk for free, by the way, for those students who are out there. And I urge anybody who's interested in this topic to go ahead and download the report and kind of dig into the sections that they are interested in. So this, what I'm going to be talking about is completely consistent with this report, but as I said, it focuses only on the transportation sector and parts that are important to the transportation sector, and adds some additional examples and things like that. About the study, a little bit about that. By the way, these are slides that were prepared by the staff and are used in general briefing. I've used the slides before for talks, but you're going to see a mixture of their slides and my slides as we're going forward. You'll know that they're the staff slides because they'll have the logo of the National Academies of Sciences, Engineering, and Medicine down at the bottom. So the committee was asked to evaluate the status of technologies, societal factors needed for decarbonization, and recommend research and policy needs. This first report focuses on the near term, the 5 to 10, 20-year period, where we need to set up the research, set up the infrastructure and policy improvements that could put us on a trajectory to achieve a long-term net zero emissions. We're continuing. We haven't met yet. We've been basically focusing on doing briefings for this first report, and there've been like 50 or 60 briefings to not only groups like this, but also lobbying groups and congressional staffers, and a number of briefings for different agencies in the federal government. The second report, so we're going to get back to work, won't come out till we'll assess a wider spectrum of technological, policy, social, and behavioral dimensions of deep decarbonization. And we're still in the process of formulating what exactly might go into that second report. And finally, this study was essentially an initiative of the presidents of the National Academy of Sciences, Engineering, and Medicine. They put in some funding. They went around and talked to foundations, and the foundations put in funding. So that's the source of the resources. We didn't bother, or they didn't bother going to the Trump administration to look for resources. The scope is federal action, so it's national. I'm not going to talk a lot about state or local initiatives. Sectors considered including carbon dioxide management, transportation, electricity, industry, buildings, and biofuels. And what the charge was not to determine whether the nation should move to net zero, only how to get there. So that's what we're going to be focusing on in this talk. This report is broadly compatible with recent announcements from the Biden administration. We've been doing, as I said, lots of briefings for them, but we had no prior consultation with the administration. And really, we were just hoping that there might be a Biden administration. We didn't even know it was going to be a Biden administration, a Democratic administration, when the report came out in January. I should thank my colleagues on the committee. It was chaired by Stephen Pakala. It included a number of people from academia, and myself and my colleague Vivian Lofness from Carnegie Mellon University. Vivian is in the Department of Architecture and particularly lended her expert knowledge in buildings, and then a variety of other people that joined into this study. The study put forward technology goals, and I'll just talk a little bit about them in a general way now, and I'll come back to them because I'm going to cover all these technology goals with respect to transportation. The first goal is to electrify energy services in transportation, buildings, and industry. So we put forward a pretty ambitious goal to have half of all vehicle sales of electric vehicles by 2030. Improve energy efficiency and productivity. While you want to pursue electrification, you also want to improve energy efficiency because that'll get us along the path to a net zero. Produce carbon-free electricity. If we're going to have the transportation sector relying on electrification, we'd like to have the power grid carbon-free. And so one of the strategies is, of course, to change the power grid so it's net zero. Expand the innovation toolkit. Triple federal support for net zero RD&D was the recommendation in the study. And then start to plan, permit, and build critical infrastructure. New transmission lines is a classic example of something that's hard to put in place, but is really important for solar fields and wind turbine fields. An electric vehicle charging network and carbon dioxide pipeline network for sequestration. Just as important as the technology goals, in the opinion of the committee, is to also pursue socioeconomic goals at the same time. So the first one we put forward was strengthen the US economy. Right now, many of the components of electric vehicles and of wind turbines are manufactured offshore, build up the US competitiveness in those areas. Support communities, businesses, and workers. This is particularly important for areas that would be hurt by a trajectory of net zero. That's the coal miners and the petroleum industry. They're going to need some policies put in place to support the transition that's going on. Promote equity and inclusion, bring in marginalized groups, ensure there's a distribution of decision-making, and ensure entities receiving public funds report on leadership diversity to ensure non-discrimination. So these are all policies, maximize cost effectiveness is another economic goal. And I'll talk about what are the costs associated with some of the changes in transportation as I'm going along. The committee's view was that you didn't want to scrap functional infrastructure early. So what you wanted to do was, in order to achieve cost effectiveness, was to look at that infrastructure that's being replaced for one reason or another. It's compatible with a net zero trajectory. So those are the socioeconomic goals. So just to give a little bit of context for this talk, the goal is to achieve net zero carbon emissions by 2050 for the transportation sector. Given that fleet turnover, infrastructure lasts a long time, research takes a long time, I think the 2020 to 2030 decade is critical for getting us on a path towards deep decarbonization. I'm going to focus on the United States, but certainly the types of things that I'm going to talk about are relevant to other countries, and a number of other countries, including China, have pledged to move towards net zero. Now, Ahmad and I agreed that this talk would focus on transportation, but I'm going to have to talk a little bit about power generation, liquid fuel, and a few other things as I'm going along. I should mention, and there's a number of references in the study, that there are a bunch of deep decarbonization studies that have been done over a period of several decades. And the studies are global, they're regional, like the European Union, they're national, they're statewide. They have varying timeframes and goals. They have varying attentions to costs and policy options. They're often based on different scenarios that might be pursued. I'm really not going to cover a lot of the other deep decarbonization studies. you can pursue those on your own if you'd like. So this gives you an idea of what's going on with respect to transportation system emissions. These are all direct emissions. So this does not include the supply chain of refineries and petroleum oil wells and that type of thing. And I've picked out 1990, 2005, and 2018. 2018 was the most recent EPA inventory of emissions that was available when we were working on the report. And you can see passenger cars is the largest emitter. Light duty trucks had been very large, but has started to taper off a bit as more fuel efficient light duty trucks come into the vehicle fleet. And other trucks, these are the heavy duty trucks, are another big segment of the carbon dioxide emissions. By the way, these are carbon dioxide emissions. It's because for transportation, that's the bulk of all emissions rather than non-carbon dioxide greenhouse gas emissions. So you can see the heavy lifting in transforming the transportation sector in the US is going to be in roadway traffic. It's going to be in passenger cars, light duty trucks, and other trucks. After that, you've got buses and motorcycles, which are fairly minor. Commercial aircraft and other aircraft are going to be a little bit of a lift, but probably the early focus can be on the roadway surfaces. Shifts and boats are there. Rail is another contributor, and pipelines is another contributor. So there's going to have to be work in all those different modes. Lubricants is included by the EPA in this list of transportation sectors. And again, it's something that we need to work on. So what I'm going to do is just work through the actions for a net zero pathway. I'll start with energy efficiency, electrification, power generation, network infrastructure, non-energy greenhouse gas emissions, and then sort of research priorities for innovations. And I should emphasize again that while you're pursuing each of these technology efforts, you want to worry about the socioeconomic goals at the same time that I put forward a little bit earlier. So improve energy efficiency and productivity. And we've been, as a profession, working on this for a long period of time and have some successes, but there's still a lot of room for improvement. One strategy is to increase vehicular fuel efficiency. One avenue there is to put in lightweight vehicles with better automation, safety, and new materials. Lightweighting should be possible. This is lightweighting, in this case, for internal combustion engines still. Switch to non-motorized modes of travel. Bicycling and walking is getting to be more and more of a priority. Switch to more energy efficient modes, trucking to rail or water, single occupancy vehicles to shared vehicles, air travel to rail. I know you have a large rail group at the university. I am confident in saying that rail is more energy efficient per ton mile than trucking. Reduce travel. That's something that we're all familiar with now that we've gone through a pandemic period. There is very likely to be more telework. I don't know if sprawl or not. We'll see what happens, and partly that's a policy choice by localities. Reduce congestion is another avenue for becoming more energy efficient. There's quite a bit of congestion, for example, that comes from crashes, incidents of one kind or another. And if we can get automated and connected vehicles to reduce the crash rate, that would be a real positive in terms of congestion. And then we shouldn't neglect the supply chain. We need to get more energy efficiency in battery and vehicle manufacturing generally. Give a few pictures to illustrate things that can be done. On the left is my grandchild and daughter-in-law. She's on her way to work. My grandchild Maggie is on her way to childcare at this point. They're in the Netherlands, and the Netherlands has invested in quite a bit of infrastructure that is excellent for bike riding. At the top center is youthful Chris Hendrickson. This was taken, I think, back in 1977. I'm sitting beside one of my thesis advisors, Carlos DeGonzo. We are sitting on a high-speed rail train in Japan. And you can see that this is an alternative to flying, which is what happens in the United States. On the far right is a picture of me on a roving robot. So I'm sitting at a console. My picture is projected onto the robot, and presumably I could telework from home and have a presence, a physical presence that could go from room to room in an office with this type of technology. Imad will be quick to tell me that pavements are important for energy efficiency. The other thing that's important is keeping good tire pressure in your vehicle's tires. So that's what's on the bottom center, is an illustration of filling up a tire to its proper inflation rate. And that leads to better energy efficiency in terms of roadway traction. And it's interesting to see what's happened from a policy perspective. Way back in the 70s and 80s, there was quite a bit of improvement in fuel economy. Fuel economy is on the right axis, and it goes from low fuel economy at the top to greater and greater fuel economy towards the bottom. Fuel consumption, gallons per milliliter of fuel, is on the left axis. And you can see the improvements that took place historically. And then there was this period from 1980 to about 2005 when most of the motor vehicle manufacturers pursued greater performance. And so fuel economy didn't really happen. And then some new regulations came in. Most importantly, the corporate average fuel economy standard. And the motor vehicle manufacturers responded with new vehicles, and they penetrated into the marketplace. And so you see that over time, the fuel economy started to improve. And included on this graph are some projections of what might happen if CAFE continues to. My own hope is that we're not still using that much petroleum when we get to 2050, that will have electrified most of the vehicles that would appear in this chart. One thing about energy and efficiency that we've learned over time is that the costs are going to vary. Some energy efficiency measures have both private and social positive net benefits, but they typically require some sort of a capital investment followed by cost savings. An example is fuel efficient vehicles. You're often paying a premium for them, but they pay off over time. An example might be battery electric vehicles. Some energy efficiency measures are inconvenient or risky, and that's when you need to get into regulation. A good example of that right now is whether shared ride services will be shunned in a post-pandemic world, because a lot of the ride of them is risky in one form or another. The other thing we've learned over time is that there are lots of policy instruments in this domain. You can have standards, you can have tax incentives, you can have grants, you can have procurement requirements, and a number of others can exist, such as changing the procedures associated with departments of transportation. So lots of room for policy innovation and effectiveness, efficiency in this avenue. Second is electrify transportation as much as possible. You hope that plug-in battery electric vehicles become dominant in urban areas. It's an open question, and it's an open question in our study whether fuel cell vehicles will ever become competitive with battery electric vehicles. Probably the best hope for that is long-haul trips. One of the things that is needed to do this electrification is to make sure that our charging and hydrogen infrastructure is available throughout the United States. The report does talk about railroads and ships. And again, it's kind of technology neutral. Railroads can be battery electric, fuel cell, or connect to power lines. Ships might switch to fuel cells, nuclear, low carbon liquid fuels. Again, there's a number of options for both railroads and ships. And I think some of the things are probably in the research and deployment phase rather than for battery electric vehicles. We're in the commercial stage where we're really trying to implement those vehicles in the US vehicle fleet. A couple of pictures of electrification of transportation. It's happened before. This picture on the top left is from the early 20th century. That's Edison himself standing beside his battery electric vehicle that's using the Edison storage batteries, and they were very proud to do a 1,000-mile endurance run. On the top right is a modern battery electric vehicle, in this case a Tesla. And in the bottom right is an example of a train running off a catenary, so running off the power grid in order to have propulsive force. One thing about battery electric vehicles, I've been kind of saying they're becoming commercial and they're becoming competitive. And in fact, the trends are that they're going to be very competitive in the future. This is a recent study that compares the cost. This is the of different kinds of vehicles. Conventional is at the far left for cars, crossover, and SUVs, and a series of battery electrics, and then a plug-in hybrid. You can see that you're paying a premium in the capital cost for your vehicle in 2018, but by 2025, they're fairly competitive in capital costs given the trends that we're seeing. And this goes along with operating costs for electrified vehicles. And so in the near future, we're going to be able to have fairly inexpensive electric vehicles for sale and lower operating costs. So this is both a social good and a private good, as I was talking about. And we're actually seeing an increase in the electric vehicles. The US has been going up steadily. This is data from 2010 to 2018. The real success story here, by the way, is China. You can see their number of sales has really gone up. Another big success story is Norway, which is a fairly small country, but has been promoting electric vehicles very heavily. Again, I should emphasize that fleet turnover is slow. The average age of light-duty vehicles in the US is 12 years. So that means that fleet turnover is requires on the order of 20 years if you're going to avoid premature scrappage. And so this coming decade, we'd really like to see electrified vehicles being sold by 2030. And good news is that many of the vehicle manufacturers are talking about the same sort of thing. Hand in hand with electrification of transportation is decarbonizing power generation. We'd like to see an increase in the renewable power generation share, solar, geothermal, and wind. Ensure a stable supply of power, as everyone points out and gets blocked out at night. Wind and some sort of a stable source of power, and that might be batteries, it might be pump storage, the heart of all as civil engineers. You might want to preserve nuclear generation as long as possible, if not even invest in new nuclear plants. And if you're going to continue to have coal-fired power plants in the power generation mix, we need to really move towards carbon capture and sequestration from those emissions. Just a couple of pictures. The top left is one I took in New Zealand. It's a long-standing geothermal plant. It produces steam that is run through steam turbines to produce power for the local area. On the right is a modern wind turbine. Those have been getting larger and larger over time as the companies that manufacture them and operate them pursue scale economies. The US has quite a bit of potential for solar power. That's the bottom center picture. I got to say our solar power is pretty marginal. But in the southwest of the United States, you're starting to see commercial plants that are utility scale for solar. The non-fossil share of energy in 2019 is about 20%. You can see from this graph, it's been growing over time. This is one that goes from 1776 all the way up to 2019. And you can see that just about all of the different non-fossil fuel sources have been growing over time. And what we'd like to see, of course, is an expansion of that and a speeding up of that sort of trend over the next decade. Coal, interestingly enough, is dropping. Natural gas has been increasing. Natural gas pricing has been very attractive to power generators. And petroleum up at the top has not been growing very much over time. That's because of more energy efficiency in a lot of transportation vehicles. So this is the sort of graph that decarbonizing the power grid and eliminating lots of uses of petroleum and natural gas is important for. And the good news is that there are a number of studies that are coming out that are suggesting that power decarbonization is affordable. This is a graph of energy system costs as a percentage of gross domestic product, which is one way of thinking about how much resources we're pouring into power and, well, energy systems in this case. And you can see the EIA reference, the government forecast, the Net Zero America forecast that was done at Princeton, and then deep decarbonization pathways. And you can see that they're all tending to go down over time. So that this is an affordable change, I think, in terms of power generation. We'll see whether or not it's politically acceptable. Fourth strategy, and I'm going to have to hurry up a little bit, is build critical infrastructure near and dear to the hearts of us civil engineers. Electricity transmission and charging stations is going to be something that's going to have to be pushed. We're going to have to expand the hydrogen filling stations. Now they're mostly centered in California. There's a possibility for putting in place carbon capture and storage infrastructure, which is certainly technically feasible. It's a matter of economics. Maybe some catenary for railroads where that makes sense in terms of the density of the traffic. And then connectivity for energy efficiency. Transportation connectivity should result in greater energy efficiency as you reduce congestion and have more efficient routings. So that's something that's a critical infrastructure along these lines. And I just have a couple of pictures to illustrate. On the left is one of my sons playing ultimate frisbee underneath a transmission line. Putting in transmission lines, of course, is a difficult political task. It's certainly not economically unreasonable because by and large transmission lines make money. It's just a matter of getting all the permits and approvals. And then on the right is just a generic illustration of carbon sequestration where you have pipelines and then you have some sort of an underground storage facility where the carbon dioxide is isolated from the atmosphere. Non-energy greenhouse gas emissions are largely out of the transportation domain, but certainly there are some processes that we depend upon, cement being a good example, enhanced land and water sequestration of carbon, because it's going to be really tough to get to net zero in some of the transportation modes like long distance air travel. And then reduce non-CO2 greenhouse gas emissions. Leaking pipelines are an issue here because methane is a fairly potent greenhouse gas. On the left, it's just regular leakages. That's in the Boston area, and it was an aerial survey. And you can see that there's quite a bit of methane leakage going on there. On the right is an incident where some sort of a fire started up and the methane is just venting to the atmosphere, and we'd like to reduce those sorts of incidents as much as possible. Then pursue useful innovations. Lots of research and deployment opportunities here. Zero emission hydrogen production for fuel cell vehicles, synthesis of low carbon fuels for ships and aircraft, manufacturing process, hydrogen direct reduction of iron to go into vehicles, energy efficient cement, carbon dioxide capture and storage processes, high yield bioenergy crops, direct air capture of carbon dioxide. This is why the committee recommended a large increase in research, development, and deployment funds for net zero technologies. So, possibilities for deep decarbonization. We have 6 action areas for moving forward. I wouldn't say that they're easy, either politically or from a technical standpoint, but I think all of them are feasible. Sustainable engineering can be supportive and critical for this effort, and the socioeconomic goals, in addition to the environmental goals, are also critical. And by the way, I mean, I've given you kind of the study in my own viewpoint, but I think that I can say that the consensus emerging from a lot of the deep decarbonizations follow very much along the lines of what I was talking about, although a lot of those deep decarbonization studies did not include socioeconomic goals. So net zero emissions have technically feasible pathways. Transportation electrification is a critical element in just about every study that goes on. Most of the studies enter electric vehicles. Fuel cell vehicles are more expensive. The battery electrics have been suffering from limited range, but as anybody who follows the new vehicle market knows, the greater and greater range is coming along as batteries improve. A lot of talk about what sort of cost this might be. It's the viewpoint of myself and certainly my committee that extra costs should not be prohibitive, and they're likely, very likely, to be less than the social costs of climate change and conventional air emissions. And supporting this is that cost reductions in renewable power generation and batteries have been real game changers in terms of what's, so over the last decade, there's been a real change in the economics here. I'll just finish up with a couple of slides from the report and then open it up for questions and discussion. The next report, we're talking about what should go into it. If some of you have ideas, just email me. You don't have to bring them up in this meeting. Things like agriculture didn't get a lot of a treatment. I think state and local is an important area to take a look at. National security implications and wider consideration of benefits like public health will probably be in that second report. And this is, I think, my last slide. You can download the report and you can download the staff slides at nationalacademiespress.edu/decarbonization. You can subscribe for updates. And as I said, there's been a whole bunch of briefings off the study, but things are moving and we're all going to be watching over the next couple of months what goes on with the Biden administration infrastructure bill in terms of what happens with new climate change possibilities. So yes, that's it. I will stop sharing and be happy to take some questions.
Yes, thank you, Chris, for a wonderful, distinguished speech today. And we already have a couple of questions. The first one is coming from Ken Runkle. So I was wondering if he would like to ask the question himself. So you can unmute yourself, Ken.
Okay, yes, thank you. Can you hear me?
Yes.
Yes.
Yeah, my question has to do with the transition period. You know, as we're gonna need electricity, more electricity for all this electric vehicles. In the short term, which is more carbon efficient? Gasoline powered individual cars or coal burning plants that would produce electricity. I know that's not the only alternative, but as we look at these two things that will probably need to continue as we transition, which of those two is most carbon efficient?
Well, I'll go back to my point about scrappage. If you buy a gasoline vehicle, it's very likely to be on the road in 20 years from now. So at that point, we should have achieved quite a bit of change in the power grid mix in the United States. So I would urge people who are interested in buying new vehicles at this point to really think about electric alternatives to the conventional vehicles. And I don't believe that there is going to be a major problem in the power grid supplying the sorts of vehicles we're talking about. With a 20-year horizon, we're only replacing 1/20th of the vehicle fleet every year. And so there's going to be kind of a long buildup in demand for electricity from the vehicle fleet. And so I think the current grid can handle that. And what we'd like to do is both change over the vehicle fleet and change over the power grid mix at the same time.
John, do you have a question?
No, sorry, I thought that was a group chat. I didn't realize for Chris, so my apologies. I agree with Chris, though. Same.
Yeah. So, Chris, I have a quick question until somebody also raised their hand. Some of the states like California, I guess, because I remember here John talking, so are already having some policy regarding decarbonization. And I think some other states in the West, they are following. So what do you expect when you are looking at the political map here in the next 5 to 10 years?
That's an interesting question. One of the interesting things that California has done is they've been pushing fuel cells. So they are the place in which you've got hydrogen fueling stations, and you've got ordinary people who are leasing fuel cell vehicles there. And so California is kind of pushing ahead on deep decarbonization, not only in the transportation world, but also in the power grid. It's interesting because even in kind of some red states like Texas, you're starting to see quite a bit of investment in renewable power. And that isn't driven by regulation, it's driven by economics. So there's quite a bit of wind turbine production in Texas now. I've read that there's some investments coming in for utility scale solar cells. And so I think part of the answer to what you're talking about will be politics, in which kind of some states buy on to worrying about climate change more than others. But other states, it's going to be the economics that are leading the way. And the trends towards net zero is pretty good, particularly if something like a carbon tax comes in, which is one of the recommendations I didn't talk about out of the study. The study recommends a fairly small carbon tax, $40 per ton, with the idea that it's not going to lead us to complete net zero, but it's going to provide an incentive for firms to move in that direction.
All right, I think, thank you, Chris. I think now John, he has a question. So John?
Actually, I think Chris Paul had the hand up first.
I'm sorry, I didn't. So I'll go to Chris Parkin. I'll go to Chris. I didn't see that. Thanks, John.
Lord, that's fine. Thanks for a fantastic seminar, Chris, first of all. And I know we're going to be talking about this in Railtech. One of the areas, if your committee considered, and it may be sort of too detailed, but you noticed in your table that, as we all understand, a huge amount of the energy is consumed by the motor vehicle fleet, whether it's light duty trucks, automobiles, or heavy duty trucks. One of the frustrations that the railroad industry has faced with regard to research on energy efficiency has been that they're already so efficient that whatever additional incremental improvements you make are kind of pale in comparison to the research on the highway side, which has the perverse effect of, in a sense, subsidizing the less efficient mode at the expense of the more efficient mode. So my point is there's a policy issue here in terms of supporting research on energy efficiency on the rail side as well as on the highway side. And the new grant that Tyler referenced this morning from the Department of Energy is a welcome exception to this rule, and maybe there's a changing trend. But my point is that I'm hopeful that your committee will be cognizant of this policy element in terms of how research is funded. We want to continue making rail more efficient at the same time, but we obviously make highway more efficient as well. Have you guys thought about this?
Well, as I said, this report was done in 9 months, and we spend everything across the U.S. energy sector. So it was hard to dig into some of the points. But let me say a couple of things. In terms of energy efficiency of operations, I think rail is very energy efficient. And one thing that one can think about is policy that would push more trucking onto the rails. And for that, rails have extra capacity in order to handle that. And there are a bunch of different policy tools, you know them as well as I do, to make that sort of a change happen over time. So that's kind of my first example of energy efficiency that one might pursue in the rail area.
Yeah, go ahead. Sorry.
The second thing is that I think the switch from diesel electric to all electric is something that needs to be pursued. And I think of that as really in the research, deployment, development phase right now. And it's unclear to me exactly what mix of electrification is going to be best for all the different railways. Go ahead. You wanted to say something?
No, I just was agreeing with what you said. But the other challenge, and you referenced it in your talk, and you know, the railroad industry has studied electrification seriously, studied it on several occasions, dating all the way back to the energy crisis of the 1970s. And there's some, you know, a lot of good work that has already been done. So that's available for the committee to. The other point I was going to make, is the grid is a huge challenge to overcome. And so I was glad to hear you talk about that, but it's going to be non-trivial to, not just for railroads, but for all modes, to completely refurbish the grid and expand the grid so that electric transmission can take place.
Yeah, our report spends a lot of time talking about what sort of investments are going to be needed for power generation and for transmission lines over time. And that's a heavy lift to make sure that the grid is stable with a lot of renewable power and that there's adequate capacity. And at the same time, that's a big opportunity for power generation operators, because they're in the business to make money, and this is an opportunity to make more money.
But somebody's going to have to pay for it.
Yep. But I mean, it's a switch from paying for petroleum to paying for electricity. So it may not be an extra cost at all. In fact, I suspect it'll be less.
Yeah. All right. So we'll go to John, and after that, Jose. John?
Hi, Chris. Thanks. A great talk. Do you think that there's a tipping point coming pretty soon? We already see some initial signs that capital investment is going to start looking at the long-term prospects of oil exploration, investing in continuing supply of coal, and that the market will actually cross over soon, and that will drive things as much as by itself as much as policy driven by government.
Yes, you're starting to see that. You're starting to see a lot of the oil and gas, traditional oil and gas companies start to become very interested in alternative fuels and trying to position themselves so that they're not going to go out of business if petroleum starts to decline significantly. They're trying to position themselves to be in the energy markets of the future. So a lot of corporations are thinking along exactly the same lines that you are, John, but they don't want to turn into dinosaurs.
Dinosaurs that mine dinosaurs. Yeah.
Right.
Thank you.
That's it.
Great. Thanks, Jose.
Thanks so much, Professor, for your. I have a quick question.
Oh, you are muted. Yeah, okay. You're good. I think when you move, your voice goes back and forth. So try again, Jose.
He's muted.
Can you
I think.
hear me now, Professor?
Now we can.
Yes.
Yes, sir.
Go ahead.
Okay, I think we lost him. I have a quick question until we get the next question, Chris. With more now going into electrification and more using the grid, do you expect more states will be now relying on nuclear power?
Well, the experience of building the new nuclear power plant down in the Carolinas has been sobering, to say the least. I don't know whether you followed it, but it's having large cost overruns, large time overruns, and litigation among the parties that were concerned there. So I don't know when we're going to see large-scale nuclear plants produced. I would say there's a great deal of attention on smaller scale nuclear reactors, microgrid type things.
Right.
And so it could well be that they start to become commercial in the next 5 to 10 years. And that would be a very useful development. Of course, the long-term problem with nuclear is we still have not gotten the political will to come up with a long-term storage solution. And so that in the United States is still hanging over us. Norway has come up with a long-term storage solution, but the US is not in that boat. And until that happens, nuclear, I think, always has a cloud over it.
Right. Yeah, I think I mentioned this because the state of Illinois, we are very heavy on nuclear energy. It's like maybe almost 70%. So I was thinking maybe other states will pursue the same. I think Jose is back. So Jose, the floor is yours for the question.
Sorry,
please.
Professor. Sorry, I had an issue with the internet. Professor, thank you for the presentation. Amazing topic. A quick question. Here in the US, we don't have standardized the plug-in that we use to charge electric vehicles, contrary to Europe that they have like now standardized that system. Do you think that that's going to change over the next 5 years? Because maybe that's one of the issues that is delaying the use of electric vehicles for long range travel. Because, for example, Tesla stations doesn't necessarily work with the GM and the other electrical providers. And one of the issues that the federal government has not wanted to standardize that plug-in or electric charging system. What are your thoughts regarding that topic?
I sure hope it gets standardized. But the corporations are pursuing their own policies, and they think that gains them share. So it's going to take some political clout to impose that sort of regulation. It's interesting that electric plugs got standardized at the national level, but not internationally. And I've always thought that was a loss because I've been traveling around internationally with multiple electric plugs that I have to use. And so that's another case in which you'd like to have more standardization. And it's difficult. It's political. It's lots of private interests involved, and there are technical issues, which type of charging you're going to have where. So it'll probably be 5 to 10 years before we standardize, but I sure hope it happens.
Okay, thank you.
Right, thank you. Our last question, I guess, from Ria. We'll make it short. So we're getting to Ria, please.
Sure. Thank you so much for your very informative presentation. I am wondering about your view on demand management. For example, how are we going to convince electric vehicle drivers to charge during the appropriate times of day, and how deal with behavior in that sense? Is pricing the only way to do that? Do smart and autonomous systems help in that sense?
Yeah, smart systems and pricing can really change charging behavior. And there's examples of that in kind of pilot programs. I mean, if I come home and plug in my vehicle at home, what I'd like is for it to recharge at the lowest electricity cost time. So I don't need it charging immediately. I may overrule the smart system that says do it at the minimum time in case I want to go out again. But by and large, you'd like to rely on smart technology and time of day pricing in order to drive charging to periods in which the grid has and production is fairly cheap. They're using their cheapest energy sources during those periods. And so I think there's a lot to be done with respect to vehicle charging, in addition to building electricity demands, things like running your dish at the low charge, low cost point is also a good strategy. So all of those things can help in terms of changing when people are actually imposing a charge.
Thank you, Chris. Thank you so much for being with us today, and thank you for meeting with our student, our faculty, and thank you for fascinating lecture today. It was really very informative, and I think we really appreciate the time that you took from your schedule to be with us today. Thank you so much again, Chris.
It was a pleasure, and I hope you all learned something, and we're all going to watch how this all unfolds in the policy domain over the next couple of months.
All right, thank you, and thank you all for being with us today, and we'll see you next week with the Kent lecture. All right.